Hi, I'm Micah Woods, Chief Scientist at the Asian Turfgrass Center. Last week, I was in Gainesville, Florida, and I gave a presentation to the turfgrass group at the University of Florida there, and I called it a quick tour of the ATC research area. I'm going to do a screencast of this now and give an even quicker version of what that presentation was to highlight some of the things that I talked about. And the title I mentioned at that time is kind of a joke because at one time there was a ATC research area, and in the presentation I talk about that a little bit, but what I'm really talking about is the geographical region where ATC does research now, and also the scope of ATC's research, the type of things that I've been studying and learning about recently. From 2006 to 2009, I did have a research area a little bit north of Bangkok, and we grew all different kinds of grasses there. And we had field days and did a little bit of research, but mostly it was more like a demonstration area. And I never really got to the point where we could make money from doing research there. And because of that, when the economic crisis happened in 2008, 2009, I went ahead and shut the research area down. And since then, I've been doing a different kind of research because it turned out that the original business model of having people come to Thailand to study and learn and do training courses, and also the business model of doing contract research there, was not a very good business model. But it turned out in the Asian region, and now even more globally, there was a demand for something that I didn't realize there was at first, and that was for more on-site consulting and the delivery of information programs. Over the past 15 years or so, on this map, I've marked some of the places where I've been, and each of those points marks a place where I've been. It goes from the west in Dubai, the south, that's actually not Asia, that's Africa in Mauritius. In the the farthest to the east is in Guam and also at Rota Island, and then a lot of places in between. In the north, the far north is in Hokkaido. So it turned out that people wanted me or invited me to go do consulting work, or they invited me to go to some of these places to teach training programs. And I'm always keeping my eye on the ground, always looking at grass. And because of that, I've had a chance to travel to a lot of places and learn about grass. And in so doing, I also started some research projects at some of these locations, and collected data from some of these locations. So it's a different kind of research area than what I first envisioned. I was giving the seminar in Florida, and prior to the seminar, I looked up what some of the latitudes are in Florida. If you look on this map, Shanghai is right in the middle, and Shanghai is basically Shanghai is similar in latitude to North Florida. And I was surprised that Key West was as far north as it is. Key West is the southernmost point in Florida, and Key West is actually a little bit north of Hong Kong. So when you're looking at Southeast Asia, at places like Hong Kong, Hainan Island, Vietnam, Thailand, Malaysia, Singapore, Indonesia, Philippines, almost all of India, all of those places are farther south than what you would see anywhere in Florida. Even so, I mentioned to the faculty and students and postdocs and technicians who joined the seminar that I think the University of Florida, because they are the closest one can get to having a serious turfgrass program, a complete comprehensive turfgrass research and education program in latitudes that are similar to the tropical environment. I think that there is a huge opportunity for me to learn from them, which is why I wanted to go to the University of Florida and look at some of the grass and meet some of those faculty and students. And also perhaps some chances for us to collaborate on a few things. So anyway, my research is spread over a large area, and I mentioned that one of the first things I noticed as I was traveling around to these different places was a difference in sunshine hours at the similar latitudes. Ishigaki Island is one of the southernmost points in Japan. And on this chart, for each month of the year, I've shown the average temperature on the horizontal x-axis and the average hours of sunshine duration on the y-axis. This essentially is what the climate is like at Ishigaki. If we call the climate the temperature and the sunshine. If we look at a place with a similar latitude, and in this case it would be Miami, if we put Miami data on that same chart, you'll notice that there is no overlap at all. Miami, which is at the same latitude as Ishigaki, which means the day length is the same, there are more sunshine hours on average in Miami. And although there is lots of overlap in temperature, there is not overlap in sunshine hours. And it turns out it's not only that city pair that exhibits this phenomenon. We can also look, for example, at Hong Kong. Hong Kong has a similar latitude to Honolulu. And Hong Kong has this area enclosed by the different months of the year with different temperature and sunshine duration combinations. And when we look at where Honolulu is, Honolulu also has higher sunshine hours. You can see that Honolulu on average is going to have more than 6 up to about 10 sunshine hours per day. Hong Kong at the sunniest month of the year, which is July, is less well, they're just above 6, almost 7. And at the cloudiest month of the year, or the month of the year with the lowest amount of sunshine hours, which is March, there are only about 3 sunshine hours per day, which is not a lot. We'll look at one more city pair, and you will see the same phenomenon. This one is Tokyo and Raleigh, North Carolina. In Tokyo, there are fewer sunshine hours, even though it's at the same latitude as Raleigh, and even though the temperature ranges are quite similar, there is a difference in sunshine hours. There actually is overlap between these two cities, but it's in the months of December and January and February. And when warm season grasses are dormant, and primarily I was talking about warm season grasses being in Florida, when warm season grasses are dormant, I don't think there's a lot of competition going on, so it doesn't really matter that the climate is the same in those months. During the months when the grass is growing, that's when I think it matters to have that's when those differences actually matter. So I noticed that, and that's something that it has a big impact on both grass selection and on grass management. One of the things that I was looking at in Florida was zoysia grasses, because zoysia grasses are found all throughout East and Southeast Asia. And zoysia grass is especially good at growing in low light conditions. I summarize this as saying that locations at the same latitude in Asia as similar latitudes in North America will generally receive a lower sunshine duration. And that's why zoysia grass is native to East and Southeast Asia and why it grows so well there. Because I had some time, because I wasn't running the research area and taking care of grass every day and supervising staff and that sort of thing, I've had some time to use R software and learn a little bit about data analysis, a bit more than I had. And one of the things that I did is make a Shiny app that anybody can use to find the amount of light at their location. What I pointed out on this one, which I downloaded for Gainesville, I looked at the weekly summaries, and the weekly summaries are what um, you can find in that little table on the left side of the chart where it says DLI range and then weeks. At Gainesville, over the past year, there were 34 weeks with an average DLI above 30. And there were only 2 weeks in the past year with a average DLI less than 20. And there were actually zero days with the average DLI less than 10. I looked up a place in China, Hangzhou, which has a similar latitude to Gainesville. And I want you to look at what the difference is on that number of weeks with a certain DLI range. Remember, Gainesville has only 2 weeks in the year less than 20 DLI, which is the photosynthetically active light, the photosynthetically active radiation. And there are 34 weeks at Gainesville. There were 34 weeks in the past year with an average DLI above 30. When we look at Hangzhou in China, which has the same latitude, so it means it has the same day lengths, there are 12 weeks in the year with a DLI less than 20. 12 weeks, which is a lot more than 2. So there's a lot more cloudy days with low DLI. And then if you look at the number of weeks in the year above 30, there are only 17 weeks. So there are half the number of weeks, half the amount of time during the year with a DLI above 30. Remember, Gainesville had 34 weeks above that level, and Hangzhou only had 17. This has a huge impact on how grasses will perform and which species and varieties will do well. So it turns out that that's something that I pay a lot of attention to. And I'm going to loop back and talk a little bit about Zoysia towards the end of this presentation. And then I went through and talked about some of the things that I have been working on in my research area, meaning area of interest or area of topics that I've worked on. And one of these was soil test interpretation and MLSN. Many people are familiar with that as a modern method for making fertilizer recommendations for turfgrass. MLSN is something that I was able to do a little bit easier because of the free time that I had. So instead of looking only at one research area, I was able to look at how turf was performing around the world, how turf was being managed around the world. And I was able to have some of those data analysis skills because I had more time to work on that because I wasn't taking care of grass. And I think that's one of the reasons why something like MLSN came about. This is a project where we took samples from Pace Turf. We took soil test samples, test results from ATC, and we put those together. And then we plotted those. And when we plot those, you can see that there is a wide range of test results. I'm using potassium as an example, and this was not meant to be a seminar about MLSN, but rather just a quick overview of how this works. There's plenty of information at my website, asianturfgrass.com. So if you're not familiar with any of these things, or if you'd like to get a link to that Shiny app to download your own DLI chart for your location, you can find all of that at asianturfgrass.com. Anyway, there are very few samples close to zero, like right around zero. There's a peak of samples that are somewhere around 75 up to about 400. And then as you get above 400 parts per million potassium in the soil, there's very little good performing turf in that range. But we make the assumption that because all of these samples are coming from good performing turf, that each one of those values is enough. And because the samples that have relatively low potassium in the soil have enough, it would seem that the ones that have more than that, that's just extra potassium, but it's not providing any benefit. when we make that assumption and then we fit a cumulative distribution function to this set of data, we can then get percentiles or percentages of the, I'll change how this slide shows so we can see all the graphs, or all the scales on the y-axis. What when we plot this curve that goes up, the green line that makes a curve, we can look, for example, at the value 100. If we look at the value 100 for potassium on the soil test on the x-axis, if we look up where it crosses that green line, it's about 75%. That's the right side y-axis. And what that means is 75% of the samples in the database had soil potassium less than 100 ppm. And what we did for MLSN is choose the 10% level. So we take the 10% level, that comes with this particular data set at a value of 37 parts per million. And we use that to identify the minimum guideline, and then we make the recommendation that you keep your soil test level above that. And if you do that, there is a high chance that your grass is going to have more than enough potassium and everything will be fine. So it's a simple modern method to make soil test interpretation and fertilizer recommendations for turf grass. Another project that I was able to do in my large research area, because I was not confined to a single location, was to recognize that no matter where I was and no matter what kind of grass I was seeing, the quality of the grass, the performance of the grass was all related to the growth rate. And somehow it occurred to me that measuring the clipping volume could be used to make a rapid assessment of that. And actually, it turns out that the clipping volume is related. The clipping volume is related to the dry weight. And we confirmed this with some research at the Nichi-no-ryoka Research Center in Chiba, Japan, where samples were collected, the volume was measured, and then the dry weight was measured. They have a drying oven and a scale. So we collected the clippings. They were dried. Well, first they were measured for the volume, and then we measured the dry weight. And from that, we can get some regression lines. We've also done research on this in Thailand, specifically with Tiffigal ultradwarf Bermuda grass, and it produces a similar line to what you'll see with champion or bent grass here. And from that, the really useful thing that I find for all of this is the ability to then predict how much growth we will get, how many clippings will be produced by the grass for a given amount of nitrogen. So I have a blog post about this called Flipping Things Around, because it doesn't make sense to me to apply the same amount of nitrogen fertilizer all the time. For example, every week or every 2 weeks, put a certain dose of nitrogen. Rather, I like to look at how much the grass is growing, how rapidly the grass is growing, to compare that to how much I want the grass to grow, and then adjust the nitrogen accordingly. And I know, based on some of this research about clipping volume and dry weight, that for a certain amount of nitrogen, I can predict how much it's going to make the grass grow. To me, that's really something I have been working on, is the OM246, which is total organic material by depth. It turns out that this is really useful because if there's too much organic matter in the soil, the surface won't perform well because the mowers can't cut short enough, because the rollers will sink in and the water won't infiltrate fast enough, and the surfaces will be too wet and soft, and the surface just doesn't perform. I've started measuring the total organic material on undisturbed samples at specific depths, and I've noticed a couple of things. This is 3 charts that are showing 4 Zoysia grass. This is for a particular golf course with Zoysia grass greens, and it's looking at three different depths: the 0 to 2 centimeter depth, the 2 to 4 centimeter depth, and the 4 to 6 centimeter depth. If we look at the chart all the way on the left that has the 0 to 2 centimeter depth label at the top, we're looking at a time series of data from 2017 up until February of 2022. And if we just look at the beginning and ending values, it started at 11.2% and it's ended at 12.5%. And the surfaces have performed excellent across this 5-year time period. And we know how much sand has been applied as top dressing, how much surface area has been removed by coring, how much verticutting has been done, and how much the grass has been supplied with nitrogen and how much the grass has grown. By looking at the change over time in organic matter, in the total organic material, at the 0 to 2 centimeter depth, it is possible to make an exact assessment of what the effect of the sand top dressing has been and what the exact effect of the growth and the decomposition have been. So essentially, we're looking at three things. The change over time is going to be the integrated combination of how much new organic matter was created by plant growth, how much decomposition of organic matter happened naturally in the soil, and how much physical change in organic matter was caused by maintenance practices such as the addition of sand top dressing or the physical removal of soil organic material. Those three things combined are what is shown in the change over time. It turns out that when you measure this, right now we're looking at the 0 to 2 centimeter depth. When you measure this, you get an exact assessment of what's happening and you can then adjust. And it turns out at this location, there's been a minimal amount of sand applied. In fact, in, what is it? It's about 1/4. I would say at this location, the average amount of sand applied per year is about 5 cubic feet per 1,000 square feet, which is about 2 millimeters. This is about 1/4 to 1/3 of the amount recommended as a standard by most, let's say by Roch Gassois at University of Nebraska. That's about 1/4 of his recommendation. And it's even less than the recommendation from the green section of the USGA. It's interesting to me that you can have relatively constant organic matter content and still do 1/4 or 1/3 of what the standard recommendation is. So this is also quite a nice thing to do when you're concerned about maybe you're not doing enough and you're able to assess what's happening in the soil. And so you've got those great surfaces on top, and then you're checking in the soil to make sure nothing's happening that you might regret later. You can also look at the center chart, which is the 2 to 4 centimeter depth. And this is showing that over that 5-year period, the organic matter has actually gone down. Now, there's been a single core aerification event over this time. So basically, it's just staying constant with decomposition. Basically, the accumulation rate from the grass addition of organic matter each year, and then the decomposition of organic matter each year in the soil, it's basically staying constant. So we have a fluctuation there where it's gone from 3.3 to 4.2. So it's the overall range is less than 1%, and from the start to the end, it's basically flat. This tells me, and we're talking here about 2.2 centimeters to 4 centimeters depth. That's just like right here. It's just this zone right here. It's from 0.88 inches to 1.6 inches below the surface. So basically there's nothing going on there, and there's been a single coring event. no solid tines over this period at that location. So it tells me that for this particular golf course, there's no need to come in and put sand down below the surface, and any adjustments to the organic matter and any additions of sand, ideally you'd put right at the surface in the top 2 centimeters. If we go down even deeper and look at the 4 to 6 centimeter depth, which is not very deep, now we're talking from 1.6 to 2.4 inches below the surface. Something centered right around 2 inches below the surface. Now it's gone from 3% organic matter at the start of this time period down to 2.2. And remember, this is just with natural decomposition of organic matter. This is not done by putting sand down there or by physical removal with soil organic. It's not removing it with coring. And if we look at the combination of those, which we can do using this test method by calculating the bulk density for each depth and then combining those, we can see that it's basically constant in the top 6 centimeter depth, which is the top 2.4 inches. It's basically constant from 2017 up to 2022. It's right around 5%. So that tells us that with that maintenance practice of doing a single coring event over 5 years and doing a minimal amount of sand top dressing, about 1/4 to 1/3 of the standard annual recommendation, maybe 1/5 if we compare it to the USGA green section standard recommendation, these surfaces have still performed very well. And now I circle back, like I said I would, to Zoysia, and especially Zoysia matrella, because that's a grass that I see a lot of in Southeast Asia, and it's a grass that is not uncommon on golf course putting greens in Asia. This is the Fuji course at the Kawana Hotel. This golf course has Zoysia grass greens, and these are Zoysia grass greens that have been there on a historic golf course that was built in the 1930s. We're looking at a facility here that's about 90 years old. So this is a golf course with Zoysia greens for 90 years. And clearly there's a lot of experience with Zoysia greens and a lot of knowledge about Zoysia greens. And I think there may be some opportunity, and I mentioned when I was at the University of Florida, I think there may be some opportunity for us to share information about how Zoysia greens are typically managed in Asia, because it seems that there will be some more Zoysia greens used in the United States. Now, I still haven't really seen any really good ones in the United States, and I think maybe the maintenance practices that are used in Asia could be a good starting point for turfgrass managers in the United States. Now, I haven't seen a lot of Zoysia greens in the United States. I know they're out there. I'm going to be seeing some more over the next few days on this trip that I'm taking around the United States. So I'm sure that I will see some good ones. But I think in Asia, it's common to see Zoysia greens. Zoysia is widely used. This is at the oldest course in Thailand. This is Royal Hua Hin. These are also Zoysia greens. And this course's Zoysia greens are about 100 years old. This course is going to have its 100th year anniversary either this year or next year, I believe. And it's not only putting greens. You can also find Zoysia on tennis courts. This is at the Royal Bangkok Sports Club. And they're nice Zoysias that perform well in the Asian climate, don't have too many seed heads, and can be used for all kinds of uses. I also see lots of wild Zoysias. Remember, Zoysia grows wild in Southeast Asia. You won't really find Zoysia growing wild in dry places in the U.S. like California, but you will find Bermuda growing wild there, but because it's too dry. Zoysia needs quite a bit of water in order to persist. And in the islands of Hateruma Jima, this is south of Ishigaki. I believe this is the southernmost inhabited island in Japan. you can find these big fields of wild zoysia, and it's interesting to see what a different characteristic you'll get in the grass when it gets traffic or when it doesn't get traffic. This is not mowed, it's just traffic on this path, and the zoysia takes a very nice growth habit. As I was at home during much of the pandemic, I was looking carefully at my grasses that I grow at home, and I started to notice a few things related to seed heads specifically, which is something that I'm quite interested now because I see some of the zoysias that have been developed in the United States and then get planted in Asia. They have this horrid seed head producing characteristic that some of the grasses that are typically used in Asia don't produce so many seed heads. And I think it would be nice if grasses were evaluated a bit more in different climates. Remember, the climate in Florida, for example, is quite different because it has more sunshine hours and it has shorter day lengths. Well, no, no, it has longer day lengths. Because it's at a higher latitude. So you have some interesting characteristics and combinations with the weather, where if you have high temperatures and short day lengths, zoysia can flower quite a bit. And I noticed that with some of these grasses that I was growing at home, where one type, for example, this PBG, which is one that I got at the Penang Botanical Garden, it's a prolific flowering grass. And the dragon grass on the right is not a prolific flowering grass. Both of these are Zoysia matrella, just different varieties, but in this growing condition, they have different seeding characteristics. This is something I'm quite interested to learn more about, because ideally, when you have a grass on a low-cut turf area, such as a golf course tee or a golf course fairway or a golf course putting green, ideally it's not going to have a lot of seed heads. And here's the day length that I was talking about. The day length varies depending on latitude. Remember, Hong Kong is something similar to like Key West. And where I live in Trang in southern Thailand, that's the yellow line going across there. The shortest day of the year is still more than 11 and a half hours. And the longest day in the year is still less than 12 and a half hours. There's less than a 1 hour difference between the shortest day of the year and the longest day of the year. You can consider that to be a short day environment for almost the entire year. Bangkok is quite similar to that, and that's why you'll see prolific seeding on zoysia varieties that have a tendency to do that in high temperatures and short days. Meanwhile, in a place like Fukuoka, Japan, which is at a latitude, if I remember right, of about 30, 31 or 32 degrees, Fukuoka, Japan has flowering events that happen about the time when the day length crosses 12 hours, because it flowers during short days, but the temperatures in the winter are usually too cold for the grass. They're always too cold for the grass to grow, and because of that, it won't flower. In Hong Kong, you probably see a bit more intense flowering events in spring and fall as the day length passes through that 12-hour mark. So that's something that I've been looking at and trying to understand with the grasses, how the flowering is related to this. And first I thought it would be related to this quite closely, but what I found in southern Thailand, in Trang, where the day length is always about 12 hours, I found that there's much more of a variety difference in flowering than there is in a day length influence on flowering. And in fact, with those varieties that I've been evaluating at home, it's more than a 1,500 times difference. So the most prolific flower, that one I showed you from Penang, that one produces on average, if I would extrapolate up to a larger plot size, it would produce 60 new seed heads per square meter per day over about an 18-month period. And the one that flowers the least is about 1,500 times fewer seeds than that. So that's something that I've been looking at. And I think there's also likely to be quite a bit of difference in disease susceptibility. This is curvularia on a particular variety of Zoysia, manila grass, on a golf course fairway. And there are other patches of manila grass. There's about five types of manila grass in this photo, and there is some Bermuda grass too, but you only see one or two of the types of manila grass are actually infected with curvularia. It does seem that there is some cultivar variability in that also. Another grass that I've seen quite a bit of is tropical carpet grass. That's not one that you see in Florida so much, but this grass is common in Southeast Asia. This is a dwarf type Ixonopus compressus variety pearl grass in Bali. And then you've got the normal type of Ixonopus compressus, like on this golf course fairway in Singapore, where it performs quite well, producing a dense stand of turf that you can cut quite short. And there are ornamental types also. This is a variegated Ixonopus compressus that I think has quite attractive characteristics. It is susceptible to phosphorus deficiency, and I was playing around with phosphorus deficiency and making the leaves a bit red and purple. But if you add phosphorus and nitrogen to it, it has a really striking green and white coloration. A couple of the things that I'm working on right now include soil sampling methods. So it turns out that I have quite a wide research area because I'm interested in so many things, and I love not being tethered to a research facility and being able to have this large research area. What I'm really excited about now is this soil sampling methods project, looking at the optimum number of subsamples required and checking whether composite sampling is even necessary. This is for nutrient recommendations, for fertilizer recommendations. And I've done a few projects about this where I've taken multiple subsamples from the same location and then taken a single sample, and then I compare what the fertilizer recommendation is from when I take a single sample to when I take a composite sample. I've done this rather extensively in a few different projects, and it turns out that you get the same fertilizer recommendation. So stay tuned for more about that. I think this is going to be the most controversial thing that I do, and I'll share all the data. Maybe it will be wrong, so somebody can catch me if I've made the wrong analysis of the data. But it goes against everything that I would have thought. It just doesn't make any sense that taking fewer samples could give you a better, well, let's say I don't have enough data to say it's better. I have enough data, I think, to say that taking a single sample will give you the same fertilizer recommendation as taking composite samples. And I know that there are a number of theoretical reasons why taking a single sample should be better. And over time, as people collect more data, I think it's better to have that data be coming from single cores. So that's one that I'm going to try to find some time to write about and get everything organized and shared, because it's something that I think is absolutely fascinating. Another thing that I've been working on is playability, because all of those things like that I've done, like grass selection and understanding how the grass should be managed in a particular growing environment, and MLSN to make sure the grass has enough nutrients, and clipping volume to make a rapid assessment of growth rate, and the OM246, which is a way to look at exactly what's happening with the sand top dressing effect and the organic matter accumulation or decomposition effect. all of those are really related to playability, because if we put those all together and do it right, we should be able to maximize the number of days in a year where we get the desired surfaces. And by adjusting all of those things that I've talked about, we should be able to do that with a minimum amount of inputs. So this comes to be a type of system of turfgrass management where we can play with a lot of these different measurements that we make. And a lot of this involves modifying the growth rate of the grass and then checking what the playability is and checking what the disturbance is. And through that, I think we have an opportunity to maximize the number of days in the year with the desired playing surfaces without too much disruption. This was my flight map for 2019, right before I stopped traveling during the pandemic. And it turns out that my work now expands a bit beyond just Asia. I've been invited to Europe quite a bit, and a number of opportunities to go to the US and Canada. I've been to Australia a few times. And it turns out that my research area now becomes something that's kind of global. And it's exciting to me that what I started in Thailand in 2006, and I had the idea for a business model that would be centered in Thailand, and people would come to Thailand to get information and to see grasses there. It now turns out that there has been an opportunity for me to do research and to learn about turfgrass all around the world, and then to share information about turfgrass all around the world. And it's been a lot of fun, and I look forward to more travel around the world coming up now that it seems a little bit easier to get into. Well, it's been easy to leave Thailand. Now it looks like it's a bit easier to get back into Thailand, and I have a lot of that fun learning opportunity about turfgrass around the world coming up. And I'll be sharing information on my website, asianturfgrass.com, where you can always find information about a lot of things that I've written about over the years on the topics that I discussed here, and probably something about just about every aspect of turfgrass management you can find on asianturfgrass.com, but obviously focused on the types of topics that I've been most interested in. That was the presentation that I gave at the University of Florida, and I hope that you find that interesting. I'll talk to you again next time when I have more information. Thanks a lot for listening and watching this.